All right, here we have notes for 8-J, probability of dependent events. So review from last lesson that an independent events are events where the outcomes do not affect each other. So remember, the most common example we gave of that was rolling the dice and flipping a coin. Those two events have nothing to do with each other. Moving forward, another example of this that we could use would be picking something from a bag. Replacing it, then picking again. And here, the keywords that we're looking at are the fact that after I pick that first item, I'm going back and I'm replacing it. So those keywords you're looking for are with replacement. With replacement. So those are independent events, like the marbles that we talked about in our previous examples. So now this time we're going to talk about what a dependent event is, and if independent events are outcomes where they don't affect each other, dependent events are exactly that, outcomes where the first event, they're events where the outcome of the first one does affect what happens in the second event. So dependent events. I'll write on the bottom line. So dependent events is where the outcome of the first event does affect the outcome of the second, or of the next event, I'm going to go with. Because there's not always only two events. There could be more than two events. So I have an example here. Drawing a marble from a bag and then drawing a second marble from the bag without replacing the first. So very similar to our other example about, picking something from a bag. But the key word here in this dependent event is this without replacing. So those keywords that we're looking for are those without replacement. And why does this matter? Well, think about it. If I pick something out of a bag that has 10 things in it, and then I go in and I pick another thing, but I haven't replaced that first one, does that bag of marbles still have 10 in it? And the answer to that is no, it has 9 because there's one in my hand. So that's why it matters with dependent events. So it matters because there is one less possible outcome. The number of possible outcomes changes. And last but not least, before I get cut off, how do we find the probability of dependent events? Well, just like we do with independent events, because it's an and. So the probability of A and B is equal to the probability of A times the probability of